Okay, so continuing with 3.1, we are in 3.1c, the third video and hopefully the last one. We're talking about the vertex form of a quadratic function. And a quadratic function, we just learned how to find all the information to graph when it's in that format, but sometimes it's in a different format. Sometimes our quadratic function is in this format, which we will be using a lot in the future. Get used to seeing, dealing with parabolas, an h and a k. When it's written in this way, okay, a couple things I want you to recognize. Again, when this number here is positive, my graph opens upward like this. When this a is negative, it opens downward like that. Okay, the vertex also is hk. So whatever number this is, that will be the vertex. I ignore the negative there. That's not part of the h. That's the sign in front of the h. So it's just the h and just the k. Now, if, for instance, this were a times x plus h squared plus k, my vertex would be negative h k. Okay, I'm going to screw you all up, aren't I? Because this has to be a negative. So in order for that to be a negative, the h has to be a negative, so that two negatives give you a positive. Okay? So that's the only time that it's going to get weird, is if there's a plus sign there, and then your h is a negative h in order to do what I just mentioned there. So anyway, I don't know that the book will get into that in much detail, but I think it's important for you to realize that and recognize what's going on there. So let's continue on. I also know that my axis of symmetry is going to be whatever h is, because see, h is the first letter, or the x actually, and an xy in my coordinate here. It's the first one, so that's going to be my axis of symmetry. And the only other thing is, the bigger the a is, the narrower my parabola is going to be. So if my a is small, it's going to be like that. But if my a is big, it's going to get narrower and narrower. Okay, so just remember that as you're going along with this. Okay, so the first example, example 5, minimizing costs. Using this vertex form of the quadratic formula right there, notice that the cost for producing X Champions golf hats is given by this function, okay, where X is the number of hats, and this is the cost to make these hats. So if we're going to make 500 hats, we're going to put 500 in there, minus 40, square it, times it by 0.2, add 200, and that will be the cost to make these hats. All right, so what are they asking us to do? A, they're asking us to find the vertex. All right, so again, the vertex is the HK. So the vertex is going to very easily be able to write 40 and 200. Okay, so not too bad there. And B, is the vertex a max or a minimum? Well, because this number here is greater than 0, there's not a negative sign in there, we know that it's going to go this way. It's going to open up. And so therefore we know we're going to get a minimum. Okay? And C, graph the function using a window that includes the vertex. So in other words, they want you to use your graphing function to go ahead and graph this using a calculator. And we can just real quickly be able to graph this at 40 to 100, where x's are 40 and y is 200, and let's just say it's right there. Okay, so we're going to graph it like this. And I really can't graph it exactly like I want because I can't necessarily find other points on here because it does not cross the x-axis here. See? It doesn't cross there. So my minimum value is at y is 200. So this spot right there is 200. The distance between there and there, okay? Because that's my y. That's how high I am above the x-axis. So part D is saying what happens to the function between x is 0 and the x-coordinate, this part right here. What happens here? Well, what happens here is my y value gets smaller and smaller and smaller until I get down here to 4,200, my vertex, and then it starts increasing again. So what does that mean? That means the cost for producing these golf hats is decreasing. The amount of money it costs, the more of these things I sell, the less it's going to, or the more I produce, the less per hat it's going to cost me. Because some things are just kind of standard, you know. It may cost me $5,000 for setup to make these hats, and if I sell one, it costs me $5,000 to set up. If I sell 500 hats, it's going to cost me $5,000 to set up, but that amount is divided over 500 hats. So the cost of producing is going to go down as the number of hats increases. Okay, so after I produce 40 hats, there's my x as I get over here, then the cost for producing them begins to increase. Again, I do not understand the business behind that, but that's just what happens with the graph there. All right, let's look at example number 6 and 7 and 8, and then we will be done. Okay, so looking at example number 6, we're going to do something that's pretty challenging. What we're going to do is we're going to take the information that they give us and write the equation. Okay, so we have to know, and this is where it comes in handy, to know more than just plugging in numbers in a graphing calculator and it's spitting out the graph. This is where it's good to know how to graph these things and know why you're graphing things and how things work in these graphs by doing it by hand. All right, so for one thing, when you have a parabola, before we even get started with this, it is either going to open down or open up. And you're going to get a minimum point or a maximum point. So let's look at this problem. Wright Sport Management had its monthly maximum profit, which tells me I'm going to have a parabola that looks like this because my maximum profit will look like that, will be there. All right, so the maximum monthly profit is $450,000, and that was when it produced and sold 5,500 of these waist trimmers. Okay, so that is the maximum. Okay, so 450,000 and 5,500. So we know that our H and our K, our vertex, is going to be 5,500 and 450,000. Now, how did I put the 5,500 as my X and my 450,000 as my Y? Well, the amount of money they made is dependent on the number of items they produced. Okay? The number of items, I mean, if I have these switched around, that means the number of items produced is dependent on how much money was made, and that doesn't make any sense. So number of items gives me a certain amount of dollars. So there's my H and my K. So if I'm writing this in this method, Okay, and remember we did this earlier. There's the formula. My h is going to be there, and my k is going to be there. So I'm trying to write this formula here. And in order to write this, I need to have an x and a y, but I need to put a number in here for a. So that means I need to solve for a. Well, my problem is I still have a y, an a, and an x. So I have three variables here. And in order to solve an equation with one equation, I have to only have one variable. So let's see what else they give us here. Its fixed cost is $155,000. That means that no matter how many of these sell, it costs them $155,000 for advertisement, for engineering, for design, for machining, all that kind of stuff. That if they make one waste trimmer or a million waste trimmers, they're going to have to pay $155,000 just to get started. Okay? If the profit can be modeled by a quadratic function of x, the number of waste trimmers produced and sold each month, find this quadratic function. Okay, so that's what we're trying to do here, is find the quadratic function. All right, in fact, they use a p of x here instead of a y. Okay, so that's the profit, depending on how many they sold, x. All right, so the only other thing we know is the fixed cost is $155,000. So let's say they sell 0 of these things. That means they just lost $155,000 if they produced 0. So remember, the x value is always the number of items. So if they sold 0, they're going to lose $155,000. So what we're going to do is we are going to put 155,000, we're going to lose it, equals a times we sold 0 okay, and we are going to go from here and solve for a. And we find that a is negative 0.02. Okay, so we go back up here to our equation that we started at, and we have a variable here and a variable here, but now we know the a value. Okay, so let's move all this up a little bit, and we're going to put the a value in here. And what we did is we just came up with a formula for this particular scenario. It doesn't work on any other problem except this particular company making these waste trimmers. Okay, so this works for them, meaning that they can put any number they want in here for x and do all of the math here, and they can find out what kind of profit they'll make based on that. Okay, so what we did is we developed a formula for these waste trimmers that works so that now we can put in a number of items sold and come up with how much profit they made. Okay, so that was example number 6. Okay, so I'm just going to kind of talk you through example 7, and again, this is another reason why it's good to be able to do these by hand. We have these points, and they make a parabola, and they want us to write an equation who have these points. Here's the parabola here. Each one of them is graphed, negative 113, 0, negative 2, 1, negative 7, 2, negative 2. Okay, notice, I had mentioned this earlier, the axis of symmetry, again, is called the axis of symmetry for a reason. It is the line of symmetry, where everything on the left and right are uniform. Meaning that if we are on the x-axis, which means our y value is 2, or a 0, and we came over this many points here, we're going to be the exact same distance this way. If we are at 0, negative 2, That means we're down here at y is -2 here. And how far is it from here to here? Well, we came from 2 to 0, so we're 2 spaces this way, which means we're 2 spaces this way. Okay, so we've got those 2 points right there. So our axis of symmetry means that we are halfway between here and here, which means the axis of symmetry is at x equals 1, meaning that according to this, when x equals 1, y equals -7. So that must mean that this is the vertex, because we're halfway between here and here. Okay, exactly. 2 there, 2 there. So that means axis of symmetry, 1 is my vertex, and here x is 1. My y is also going to be, my y is going to be -7. All right, so I've got my vertex, which means I can write my formula as y equals a times x minus 1 squared minus 7, because those are it's my h and my h and my k. Again, just like on the last one, we can't write this as a formula unless we find a number to put in here for x, or I'm sorry, for a. So what we're going to do is we're going to take any one of these points. Doesn't really matter. The book took point 2, -2, plugged the 2 in here for x and the -2 in for y, and found that a is equal to 5. So now we've got the formula right there. Okay, so that is the formula that they wanted you to come up with. Given the vertex, you are able to find a, and then you put the a in here and then make these back into x's and y's, and you have the formula. Okay, and finally example 8. We are going to take this equation, written in quadratic form, and we're going to translate it into that form, into the vertex form of the equation. Okay, so in order to do this, we have to find the vertex, and then we'll go from there. So the vertex is quite easy to find if you remember. It's that and that. So we take, and remember again, this is A, B, and C. So we're going to do the -b over 2a, and we're going to find out that this is 2. We're going to take that 2 and plug it in for x in that equation. And once we do that, our y, or our f of -b over 2a, is going to be -3. Okay, so that's all well and good. So now we've got ax minus 2 squared minus 3. Okay, so we're getting there. We have to find a now. Once we find a, then we're good to go. But one thing that we know about a is that it's the same here as it is here. Okay, a doesn't change. So I know that a is 2, so I'm going to erase this a right there, and I'm going to put a 2 in its place. And I am done. I just translated it from quadratic form into vertex form, and that's it for 3.1.